Anybody else in the Twitch? Yay. Okay, awesome. All right. Well, hopefully that video was helpful. So the idea here is this tells you whether the two waves are off by a whole cycle, which means they still line up. Right. So this will give you, at that point, you have the same wave, but double amplitude. So double crest, double trough, double zero, double crest, double trough. Okay. This all making sense? What do we call this? This gets a specific name. Logan brought it up earlier, but I don't know if he's there in the Twitch. Yeah. So I'm going to be a little picky. Maximum constructive interference. Usually we just say constructive interference. That's like the sort of common. Yeah, there you go. Hi, Logan. Sorry about Twitch dying. Maximum means they're as aligned as they can possibly be. Okay. What about, God, these circles are really bad. A point like right here, HI. So at I, our phase difference is going to be, so it's like pi, 3 pi, 4 pi, pi, 3 pi, 5 pi, 7 pi, 9 pi, 10 pi. No, that's not right. It's going to be pi, 3 pi, 5 pi from my first source, and it's going to be pi, 3 pi, 5 pi, 7 pi, 9 pi, 10 pi from my other source. So my delta phi is going to be 10 minus 5, which is 5 pi. Okay. Like, I guess I erased it. That point where it was going to be 0, I don't remember where that point was. Oh, there we go. Right, remember it's C, where it was the crest for one and a trough for the other. Right. If we have crest for one and a trough for the other, our delta phi is going to be something like pi, 3 pi, 5 pi, 7 pi. It's off by n and a half cycles. So just like for the crest and crest, right? It'll go double crest, double trough, double crest, double trough, right? If they are out of line, so our crest arrives at the same time. So this crest arrives at the same time as this trough. This trough arrives at the same time as this crest. This crest arrives at the same time as this trough. Our crests and troughs will line up. And we always get 0. What is this called? This pen makes my hand hurt. It's important that you know that. What is this one called? Fancy word for line. Yeah, it is another type of interference. How do they superimpose if they are coplanar but not necessarily collinear? Intersect at 45 degrees. Yeah. So it's basically like you have two things coming along, and then they will both reach, I guess, the camera, right, at the same point. So either the crests are arriving at the camera together, right, even though they're coming from different positions, right, versus if they're out of sync at the camera, right, by the time a crest arrives from this source and a trough arrives from this source, they're going to cancel out. Does that make sense? So they superimpose, but it's only at that point. And that point will just oscillate up and down, just like it did when there was just one wave going past. But it's going to oscillate up and down equal to the displacement from this one plus the displacement from that one. So if they're crest and trough, it's going to go to 0. Makes sense? Yeah. It's kind of like a weird mental picture. If we go back to our little video here, right, and we look at a point like right here. Can you see my mouse? Oops. Like right here, right? This like dark spot right here where my cursor is. Okay. No light spots ever go past that point, right? No crests, no troughs. It's just 0 all the time. So it's always either crest and trough arriving, 2 zeros arriving, a trough and a crest arriving, 2 zeros arriving, a crest and a trough arriving, 2 zeros arriving. You just always get 0. So what type of interference is this? So constructive means make bigger. Destructive, yes. In fact, it is perfect destructive interference. And again, we usually say destructive when we mean perfect destructive, but the technical term is perfect. Someone's got to be the first one to say it. Okay. Does this make sense? Okay. What about stuff that's in between? What you end up with is like the crest doesn't quite line up with the trough, but maybe it lines up with like this wave arrives at the same moment as this wave. So this one's not quite a trough, this one's not quite a crest. They don't quite line up. So this is generally, it could be, let's say, if each starts with an amplitude little a, right? So from here to here is little a. From here to here is little a, right? If the combined amplitude, so the actual motion of whatever particle is at this location. Oh no, frozen video? It looks okay to me. Oh no. It looks all right for me. I don't know how to fix it. Is the screen still okay? Because if the screen's still okay, then I'm okay. Logan asks, what is the difference between perfect and maximum? I don't know. I don't know why they're not perfect constructive and perfect destructive. That would make more sense, but no idea. Okay. Yeah. I guess to stop you getting them mixed up as much, maybe? It's very strange. Okay. If they're combined amplitude. Okay, Skylar, can you still see like the screen even if you can't see my expressive face? Okay. I'm just gonna hope it unfreezes. I think that's gonna be my tactic here. Yeah. Okay. So if the combined amplitude is 2A, that's max constructive. That means that they're interfering as perfectly as they possibly can. If they are something between 1 and 2, this is constructive but not maximum. So the two waves add up to make something bigger, but not maximum bigger. Okay. If it's less than the original amplitude, it would be destructive because it's smaller than just one wave by itself, but it's not totally zero. And then if it's totally zero, it would be perfectly destructive. Perfectly destructive. Oh my God, there's a golden retriever outside, and he is just going freaking nuts. Oh, he's so cute. You know what? I don't know if Halfway has a name. It's a really interesting question. We can name it. We've been doing well naming things so far. Steps. Pointless interference. Doesn't make any difference whatsoever. Two waves become exactly the same as if you had just one wave. Fancy line. Okay. All this making sense? Okay. This combined amplitude we call A is the combined amplitude. I know this is dumb. If you have one wave, A is just the amplitude. If you have two waves, A is the combined amplitude, and each one has little a. I know it's not my idea. There is some math for this. I don't know if I really want to talk about the math. We have a very limited amount of time together. So it's basically what happens if you do D1 is A sine stuff plus, and then you add D2 is A sine, this is its phase, this is its phase. If you add these two together, you end up with your new wave at that specific point is A sine phi 1 plus A sine phi 2. And then you do some trigonometry identities for what happens when you're adding two sines together. You end up with, sorry, I have the hiccups. Essentially, you end up with the average of your two waves, but it has the same lambda, same t, same v, same all of those things, etc. And then you have an amplitude, A, that is given by, it's the absolute value of 2. Yeah, this is all one equation, but you're never going to use it. The bit that's on your formula sheet is this bit. And this is the bit you're going to use. So the amplitude of your combined wave is the absolute value of 2a cosine delta phi over 2. So if we look back up here, we had when delta phi was some multiple of 2 pi, right? Delta phi equals 2 pi, 4 pi. This is when we had double crests and double troughs. If we think about what happens if we plug that in, cosine of, let's say, 2 pi over 2. What is the cosine of 2 pi over 2? Well, that's the cosine of pi. Cosine of pi is -1. Absolute value of that is 2a. Max constructive interference. What about if we have some odd number of pi's? It's off by a half cycle. 5 pi, etc. We do a equals 2a cosine. Let's do the regular pi over 2. What's the cosine of pi over 2? 0. Amplitude is 0. You get perfect destructive. What if it's something in between? Let's say it's 3. It's not pi. It's just 3. That's too close to pi. Let's just say it's equal to like a 1. 1 radian. Okay. Well, we do a equals 2a cosine of 1 radian, 1/2 radian. Cosine of half a radian. Remember, your calculator has to be in radians. Radians, cosine times 2. I get 1.755a. So this is constructive because it's greater than 1, but it's not maximum. Okay. That's fair. The math is a little bit challenging. Okay. You're doing pretty good. What? I've got 20 minutes. Okay. Let's talk about how you find delta phi. Delta phi is the key. How do you find it? Magic. Well, you can look at a picture. That's what we've been doing. That's the sort of easy version. But you can also look at the math. Okay. So you have delta phi is phi for one of your waves minus phi for your other wave. We know that phi is everything that is inside the sign, right? So that is kx plus or minus omega t plus phi naught. Okay, 2 pi over lambda, yeah, but the whole thing. So to get delta phi, it would be k2 x2 plus or minus omega 2 t2 plus delta phi naught 2 minus k1 x1 plus or minus omega 1 t1 plus phi naught 1. Okay, so this is the phase for wave 2 and the phase for wave 1, and I'm subtracting them. Some of these things are the same. K2 is the same as K1 because we said that they had the same wavelength, right? Omega 2 is equal to omega 1 because they have the same period. T1 is equal to T2 because we are interested in the same moment of time for both of them. So what that means is that this term and this term just cancel. Totally gone. So we are left with delta phi is k x2 plus phi naught 2 minus k x1 plus phi naught 1. So I can simplify this to k x2 minus x1 plus phi naught 2 minus phi naught 1. And then that gets written as k delta x plus delta phi naught. So we're interested in the same moment of time, so t equals t. We're interested in the same position, so why isn't x equal to x? The reason is x is measured from the source to the point we care about. Point we care about. Okay. So if I have one thing right here that's making waves, and I have a source right here that's making waves, and I want to know what is happening at this point A, what type of interference. X1 is this distance. X2 is this distance. So our delta x, x2 minus x1, is what is called the path length difference. It is how much further one wave had to go. So for example, we have two waves with the same phi naught. We're going to talk about what that means. Oh, oof, pardon me. Each have lambda equals, phone's making noise. Thank you. Lambda equals 6 meters. What interference at the following points? So let's say I have, here's one source, here's my other source. I'm going to call this one location. I'm going to call this one location. I'm going to call this one location. I'm going to call this A, B, C. These are just different locations. So A is halfway between. B is, let's say, 5 meters. Let's say this is 11 meters. Let's say that C is 20 meters. And let's say this is 5 meters. Okay. Can you tell me what type of interference we have at A? We're going to use this equation. K delta X plus delta phi naught. I'll copy it down here. Tell me what you think. What is 1 and 2 again? 1 and 2 are the sources. So these are where the wave is coming from. That's pretty funny. She should be glad she's not a physicist. So what I want to do is find delta phi at point A will be K times X from number 2 minus X from number 1 plus delta phi naught, which in this case I already know is 0. It is perfectly in between, Logan. So what do you think we get? Physics is great. So much fun. Your hunch is telling you 0. You are correct, because this distance, x1, is going to be equal to this distance, x2. So this is K times 0 plus 0. So delta phi is 0. We can do our amplitude is 2a cosine of 0. So we get 2a, that is max constructive interference. Good job. How about it B? Would B be at 5? So B is 5 meters away from source 1 and 11 meters away from source 2. So it would be x2 minus x1. So it would be 6 meters. is in this case. We're going to talk about when it's not very shortly. $20 meters minus 5 meters. Doesn't matter which is first. Makes no difference whatsoever. At least in this case, where delta phi is 0. So this is 2 pi over, let's see, we can divide these by 3. Constructive. Makes sense? Thumbs up. Positive emoji in the chat. Yay! Awesome. Okie dokie. So do you see a pattern here? If our delta x was lambda, we got maximum constructive. In fact, if delta x is lambda, 2 lambda, 3 lambda, etc., we're going to get max constructive. In this case, our delta x was 2.5 lambda. We get perfect destructive. If one wave takes half a cycle longer to get there, then they're going to be off by half a cycle and interfere destructively. Okay. Good. Sometimes, usually you are given a question that looks more like this. 2 speakers. $3 meters in front of, I think, on the final homework. So how this works, you think about, okay, I have a speaker here, I have a speaker here. They are 5 meters apart. It's constructive. Let's see. Cosine. So I get almost max constructive, but not quite destructive, right? And you hear kind of different parts of the room will have different. So an ambulance driving by is actually a slightly different thing. That's Doppler effect. That's if your source is moving. Lines and antinodal lines. Right. Nodal lines are all these places where you get destructive, perfect destructive. Antinodal lines is where you get max constructive. Okay. So in our little video, this would be an antinodal line. I think it shows you. It'll draw some arrows in a second. Maybe. Where are the arrows? There they are. Aha. Come on, arrows. I know you're there. There's a guy doing a great 1950s voiceover on this. There we go. Those are the nodal lines. Water, it's something called a wave tank or a ripple tank. They have little things that stick down in the water and make ripples. Get through what I wanted to get through. Can I talk about Because I wanted to leave all of Tuesday to talk about standing waves if I can. It's not super necessary, but make life a lot easier. Will you let me talk about phase difference for just a second?